Approaches in Urban Design for Climate Action. My name is Jaco Manalang. I'm from the Architecture Communication Studio Laboratory, and I'll be your host for today. So nowadays, planning has become more complex of a task that we need more specialized tools in helping us gathering more complex information. And such of those tools we are going to discuss here in this seminar. It's called GIS, or Geographic Information System. GIS, or Geographic Information System. So what GIS does basically is it lets us organize different information. So for example, we have information 1, information 2, 3, 4, 5, 6, 7, and GIS lets us see it in an organized way, usually in a 2D format, in a 2D map format. Again, GIS lets us see information in a more organized way. So for example, we have people, buildings, cars, geographical features, roads, flora, fauna, we have those features. So also the sun and the wind path, we can see it in GIS in an organized way. Also, it also includes the non-tangible stuff like tradition, maybe, culture, demographic information, trends, cash flow, maybe crime rate, etc., etc. Our speaker will discuss this further in this seminar. All right, so I'm happy at least 87 of us registered for this seminar. Now, from right now, I'm already congratulating each and every one of us for registering and taking this initiative, because we can learn new things. I can already say that madami tayong matututunan in this seminar from our two speakers. All right, so before we proceed, just a little housekeeping. We are requesting everyone to keep all our mics muted, especially during the presentation. And also, we are requesting everyone to show your faces. If you can turn on your cameras, if your bandwidth allows or your setting allows. At least we feel more present at the moment. So pwede ba yun? So makakapag-open ba tayo ng cameras? Ayun, so I can already see faces. Or maybe baka makita tayo ni Crush. So okay yun. All right, so also if we have questions, i-type lang natin sa may comment section in this part. Tama ba? Nandito sa part na to. All right? And or pwede nyo ring kayo na yung magtanong personally sa ating speakers after the presentations. All right, so to kick off this webinar, we would like to call for Professor Rochelle Rhea Barria, the head of the UDSL UPCA, for the welcoming remarks and introduction. So everyone, let's give Professor Rochelle a big round of applause.
Thank you, Jaco. Good afternoon. The call for cities for climate action has long been a global priority, and the moment to act is now. Our cities are our major contributors to climate change. According to the UN Habitat Report, cities consume 78% of the world's energy and produce more than 60% greenhouse gas emissions, even if they only occupy less than 2% of our world's surface. The global community has been promoting this call with the Paris Agreement of 2015 and the adoption of SDGs 7, 11, and 13. It is noteworthy that 10,000 cities have committed to reduce carbon emissions by 2050. In the Philippines, there is Climate Change Action Plan 2011 to 2028, which charts the strategic direction of the country for ecological and environmental stability, climate-smart industries and services, and sustainable energy, among others. The Medium-Term Development Plan of 2017 to 2022 reports the findings of PAG-ASA that by mid-century, or in 2035 to 2065, the Philippines is projected to have an increase in average temperature from a range between 0.9 to 1.9 degrees Celsius and to a range between 1.2 to 2.3 degrees Celsius. have weather conditions brought about by extreme rainfall in Luzon and Visayas, and experience a rise in sea levels affecting our coastal towns. The inclusion of climate change considerations for climate resilience were evident in its 9 priority sectors to achieve the ambition natin 2040 vision of matatag, maginhawa, at panatag na buhay. The call for climate action for cities is being heard by the professionals and academe in the design and built industry. As architects, professionals, and students of architecture and landscape architecture, we are challenged to lead and apply innovative tools to plan and design for climate action. One powerful tool in planning and designing for climate action is the use of geospatial-based programs. It allows us to map, analyze, and visualize different climate data and other factors relating to the urban realm. To quote GIS practitioner Jack Dangermond, since climate change is considered as a geographic problem, it will need geographic methods to solve them. Equipping our students and target audience with the basics of GIS program and how they can use it for analysis and visualization in designing climate resilient neighborhoods and developments are seen as some of the ways our urban design studio laboratories and architectural communication studio laboratory can contribute to climate action. With this, we welcome you to Urban October 2021. The University of the Philippines College of Architecture, led by UDSL, ACSL, and the Research and Extension Program Offices, is pleased to welcome and present to you our speakers for today. Outstanding Young Scientist for 2021 awardee, Dr. Arnold Salvation, an urban designer and landscape architect here at Pueblos. They will walk us through with an introduction to GIS and its application to urban design, site planning, and architectural design, with the goal of exploring fascinating possibilities for our climate agenda. The program and mode of delivery for our webinar is geared for a more casual ambiance and consultative dialogue. Should you have questions for our speakers, please feel free to comment in our Zoom chat box at any time. Kindly write your name and institution with your message to be properly acknowledged. I don't want to keep you waiting any further, so sit back, relax, and have an enjoyable time. Thank you.
All right. Thank you, Professor Rochelle, for giving that meaningful welcoming remark. Indeed, we need to take action to climate change, and as planners ourselves, as designers, we have our own ways, we have our own methods. We definitely can contribute to our current situation, especially with the use of GIS and similar programs. And also, Ma'am Rochelle have mentioned that we have more programs to come. We have more webinars to come. So we'll keep you guys posted in our Facebook and an email. All right, so without further ado, let's proceed to the main event. I'll be introducing you to our first speaker, Dr. Arnold Salvation. Dr. Arnold is an agronomist, environmental scientist, and a geographer. He has more than 15 years of research experience in the fields of agriculture, natural resource, applied climate science, human ecology, quantitative geography, and geographic information system. Currently, he is the editor-in-chief of the Journal of Human Ecology and serves as the editorial board in 2 journals under Springer Nature. He is a graduate of the University of the Philippines with a bachelor's degree in agriculture, a master's degree in environmental science, and a PhD in environmental science. His interests include applied GIS, spatial epidemiology, spatial analysis, climate variability and change, and open source computing. Okay, so i-check ko lang muna tong aking picture dito, yung camera ko kung may lumalabas na ba na dugo. Kasi ang lupet ni sir, si Dr. Arnold Salvation. So he's quite an established man. All right, so everyone, let's give Dr. Salvation a big round of applause.
Okay, magandang hapon. Thank you, Sir Jericho.
You're welcome, sir.
Let me share my screen. Actually, wag kayong Yung intimidate doon. Ilagay ko lang yun para kunyari madali. Anyways. Good afternoon. My talk, the assigned topic for me this afternoon is about introduction to Geographic Information System. I try to add some applications, especially in the condition of the Philippines, so that our audience could have a localized overview of how GIS has been used in our country. But just to give you some background, I think the GIS field in the Philippines started long way before, I think 1950s or 90s. But it just recently that there's an explosion of interest, especially with the surge of different environmental data. That now I think even in other schools there's been interest in the use of GIS, because before I think it's only the UP Diliman of a proper course for GIS, but I think now I think other universities have as well. Anyway, so what is GIS? GIS, as been mentioned repeatedly earlier, stands for Geographic Information System. So as a system, it has different parts. Later, I'll discuss the different components if you want to establish a GIS system. For example, in your school or in your lab. Okay? Based on the S3 definition, or the Environmental Systems Research Institute, who developed different GIS applications. So it is a computer-based procedure designed to capture, manipulate, manage, analyze, and model, and lastly, display spatially referenced data. So when we talk about GIS, it's more on the spatial data or geographic data. But recently, the techniques in GIS has been also used in human systems. For example, the human body, they use GIS or spatial techniques, which is more on the GIS techniques, to analyze, for example, the pattern of tumors, the pattern of disease, etc., to relate it on a holistic perspective on the human physiology. Okay, so what the good thing with GIS, it allows us to interpret, visualize data, and to see trends which cannot be seen by the naked eye. For example, for this one, this is as you can see, the poverty incidence. If you just look in the map on the left side, you'll just see, these are only red colored maps with different gradient. But if you do some statistical techniques, which also could be done in GIS, you could actually delineate which we call the clusters. So later you could do targeted policy analysis or targeted response or policy intervention. You could easily do that. And this is what we call in GIS or in statistics is statistically significant. So this cluster does not occur in space randomly. So there's something pattern. So then out of these clusters, you could do different hypothesis tests and so on and so forth. So from this on, unlike before, we're used to when we develop our problem, our research problem, we start with hypothesis. But in GIS, you could start with the data, you visualize the data, you analyze, you check the data for any pattern. Then from that on, you could do your hypothesis testing. So that's a different way. Okay. Next. So these are the typical questions what the GIS could answer. And I believe most of you are already been using, if you're not aware, your Waze, your Google Maps. So these all technologies, even Facebook, they use GIS to do the everyday operation. So these are the typical questions you could answer in GIS. So what is the name of the village? Where is it? What going to happen if you change something? So you could do also scenario analysis. There's a lot. Actually, the as I quote Jack Dangermond, who's the founder of S3, said, the limitation of GIS is just based on the imagination of the researcher. So there's a limitless application of GIS. So it's like statistics and economics. So you could jump from one field to another. So this, the concept is the same, but the application could be wide range. Okay. So another thing to do with GIS is could simplify presentation, as like this one. This is I think this is the Facebook data 2010 for 2010, but just putting it on the map, you could see the connections between people, between countries, which country those have lots of users, which don't have lots of users, and so on and so forth. This is a classical example I used to show my students how the power of GIS could go into. Example, this is a population of Marinduque. It's a province where I came from. So as you can see, there are 219 barangays or villages. So if you multiply that from 1990 to 2010, so around 1,095 data points. So what we're gonna do? So how do we summarize these data sets into a meaningful way? Of course, if we're new, we're gonna use Excel because it's very easy to use Excel. You just click and point onto the data, and then Excel will make graphs for you. But the problem with this one is this is only for one municipality in the province. And there's 6 municipalities in the province. So if you put all these data sets, so 1,095 data sets, so your graph would be crowded. Okay, but if you use GIS, you could easily see the patterns from year to year. You could see the changes, and you could, cleanly present your data set without going to a lot of bar graphs or a lot of line graphs, where your audience cannot decipher what you're trying to convey. Of course, in GIS also you could create information by combining existing data. So this is a study I conducted last year, 2020, published in New Journal. So I combined these 8 maps to produce or to estimate the soil erosion in my province. So this way I could help local government to plan their land conservation by just putting it up. So that's how powerful GIS is. Also, you could visualize data, which you cannot do with the what you call the static maps and the graphs. This one, I think this one is the wind map of the United States. So I think if you present this to your audience or to your, for example, investors, you could easily appreciate what you're talking about. And I believe there's a research project who got a huge amount of money because they capitalize in the fascination of some administrators when you present maps to them. So they capitalize on that. I think they get 3 billion something peso for the project. So these are the components of GIS if we're trying to develop a GIS system in our laboratory or in the classes in the college. So first you have to get people, you have to have software, you have to have the data, the hardware, and the approaches. So I'll go through quickly each of the before GIS is only limited to GIS specialists or those who really study GIS or geographers or geodetic engineers. But now, I think anyone could use or could do GIS. Just on how level your enthusiasm is, or how level or how far you would want to dig into the field. Okay, so this is the salary of a GIS specialist in the United States. They have region 24 hour, $21 region income. Why I'm presenting this? This is the problem. Why some of the best GIS specialists in the Philippines are now in other countries because they pay more compared to the Philippines. In the Philippines, I think GIS is just considered additional skill and not a practice itself. Okay. For the hardware, of course, you have laptop, desktop, smartphones, and tablets. You could also do GIS. And then the software. So there's a lot of software, and there's a lot of software coming in, also additional software coming in. But of course, there are commercial GIS software. These are the expensive ones. I think one of these could go as high as $10,000 for the licensing for a specific version. Then I think, I don't know if every year you have to want to upgrade, you have to pay additional $1,000, something like that. And if you don't have money or you don't have the capital to venture in this commercial software, you could also use. There's also a lot of open source GIS software. So these are free, open source, and downloadable. You could copy it, you could modify it, whatever you want to do with the source code. You could do whatever you want to. This I advise this for my students because we know that, of course, in the university we have a license for commercial GIS software, but once they go out, so that's where the issue comes in. And I don't want them to, to go to the different sites where you could get torrent or pirated copies, because I don't want them to practice those things. And then there's also GIS on the cloud. It's like Facebook. You could just log in, then you could do all your data software is already there. These are more scalable for example for more mobile companies. And then data. So there are a lot of data sources you could use for GIS. Satellite imageries, field surveys, printed maps and reports. You could dig in. Before year 2005, I don't know, we used to dig in maps from Namibia, and sometimes even old maps, just to get digital data for our project. But now I think there's a lot of data available online. You could just download it and modify it for your use. So these are the tools. Satellite data, the LiDAR data is also coming in. Companies like Mercedes-Benz, BMW, they're investing a lot of money on LiDAR data set because they're planning to have in car of the future where it's an autonomous car. You could drive itself. You just pinpoint your route, and then the car will drive you through the destination. Okay, so there's the total station, the survey instrument, and then the GPS. Before we used GPS, but now I think most of the KA students have smartphones, and most of the smartphones they have GPS receivers which you could use also to get data from them. Okay, so these are the satellite images. This example, and then also the crowdsourcing. There are a lot of volunteers now who do the crowdsourcing, who do the mapping. Even non-GIS or non-geography student, they do mapping just for a hobby. Okay. One time one of my colleagues used data from OpenStreetMap, and I think something happened with the attribution of the data. We got a knock on our door and asking my colleague why he did not attribute the data that he used to the software, to the crowdsourced data where he got the data set. So and this student is not even a geography or environment student. He's a sociology student. So imagine that, a sociology student or philosophy student knocking on your door, calling your attention because of maps. Okay, so this is the OpenStreet data. These are the data that are available for the entire globe. As long as there are volunteers who want to map, they could submit their data sets here. Okay, there's also fieldgis.org, but I don't know. I think at the moment the website is down or been hacked by some. Anyway, so this is the data clearinghouse for the Philippines, where you could get mostly environmental data and administered data for the entire country. Okay? So there are a lot of data sets available online like before. You have to manually edit them or digitize them just to have them on your machine. Okay. Just walk through this one. There's a lot. World Bank, international agencies, they have all the data sets available. And though for those who want to study human settlements, there's also the global human settlement layers, which you could also download from this is the satellite agency of Germany. And then also the global urban footprint, where you could study urbanization or settlements for the entire world. So there are several approaches in GIS and techniques. This include querying or reasoning, measurement, transformation, descriptive summaries, similar as our basic statistics, and then optimization and hypothesis testing. I'll just run to this different techniques. So querying, like any database, because GIS is highly rely on database. So you could query your database. You could, what I mentioned earlier, you could check what's the name, where is it, what's the area. Let's do that. The spatial query. Are these settlements inside a danger zone? Something like that. You could easily do that. Okay. So the delineation of the danger zone, for example, for the Mayon volcano and Taal volcano, mostly they use GIS to easily delineate those areas because they cannot send people in the field, having tape measure. You can say, Brad, you hold the tape measure, you go to the tip of Mayon, and I'm gonna pull the tape measure and walk through until I get 7 kilometers. So that will be dangerous and litigious. Okay, so you could easily use GIS within minutes. You could already do that. To do measurements, to do transformation in GIS. That's what I shown earlier. Okay, from environmental data, you could transform it to soil erosion data sets. You could also do descriptive summaries. You could do numerical analysis. So you could measure trends, centroid. You could, where's the center of, for example, a settlement? You can measure that. The geographic center for this village, this municipalities, etc. You could also the standard deviation, the ellipse. So you could how far or what's the standard distance of each of these houses from the settlement center. And you could also do trend analysis. So what is the shape? What explains the shape of the settlement? Okay. So optimization, we do this study on data optimization. You could also do that in GIS. This is a classical GIS problem. Actually, this is also a classical mathematical problem, a traveling salesman problem, where you could you find the optimum route. For this one, we did the optimum route for Marinduque again. So for example, if you're a tourist and you want to visit the province within 1 day, 8 hours. So these are the tours, these are the routes that you might want to follow to get the most out of your visit. Okay. To do hypothesis testing, let's do that. Because in GIS or in geography, there's what we call the spatial dependence. Everything has Waldo Tobler, the father of geography. Everything is related to everything else, but many things are not related than distances. Actually, you could see this, for example, in real estate, high-end real estates tend to cluster to each other. You cannot see. It's hard to see. For example, high-end real estate, and then there's slum. They're real estate, and then slum again. So I think they don't do that. And even in our language, almost you could see people from the Visayas, they tend to speak similar languages. Okay. So here are some applications I did on using GIS for climate risk assessment. Okay. So you could do this one. Hopefully this would be published by February next year, where one of your colleagues, my co-author. This is on the vulnerability assessment using fuzzy logic and principal component analysis. Here we try to estimate or find, delineate those areas in Marinduque which are highly vulnerable to flooding. So we combine these biophysical parameters, slope, the rainfall, the elevation, distance river, and so on and so forth. We combine it with socioeconomic variables to come up with this one. Yeah. So we combine this map to the bivariate map. So hopefully we could easily help the LGU in planning their response, response in case a flood happens in the province. Almost done. Most of slides. And then this one is recently published I think 2 weeks ago at LCBR. So this is mapping drought hazard assessment of the Philippines. So I downloaded climate data from 1958 to 2019 for the Philippines, do some calculations on the drought severity, drought intensity, drought frequency, and total drought events, and do some principal components to combine these indices to come up with the drought hazard mapping. So I combined this, again, 8 maps with this one. This one, I think this is the last one. This hopefully will publish next year. So soil erosion modeling under future climate change. So what's going to happen for climate change? So based on this one, as you can see, they're expected to have increase in soil erosion rates in the province, which I recommended to do some soil conservation and agroforestry systems just to mitigate, because if you don't do anything, wala pa rin mangyayari sa atin. I think that's all. Maraming salamat po. I hope it's not too fast.
All right, so thank you, Dr.
Something.
Arnold, for that very informative presentation about the introduction of GIS, or Geographic Information System. Indeed, with the use of GIS, we can interpret data in a more visual way, as Sir Arnold have mentioned, which for us planners, this will almost always translate to better design. And for the policymakers, this can also translate to better or more informed decisions. And it's also interesting to see the connections among different people, especially far away, even from distant places. Okay, so it's an interesting thought for us to fathom that there's an invisible line that connects all of us. Meron ngang quote doon na sinabi si Sir Arnold na everything is related to everything else. Something like that. And also GIS is already an established system of people, software, hardware, and approaches. Ginagamit na pala natin yung GIS without us knowing in one way or another. And right now, I'm just reminding everyone na kung meron kayong questions, just post it in our chat box and we'll entertain those later after the second speaker. Or you may want to ask questions yourselves. Antay lang natin yung dedicated Q&A portion natin right after the second speaker. All right, so I'll be introducing you to our second speaker, Architect Kir Pueblos. Very interesting name, Kir Pueblos. So Architect Kir, just gonna wait for the screen. All right, so Architect Kir Pueblos is a landscape architect and an urban designer experienced in a multitude of projects across the Philippines, spanning master planning, urban design, cross-regional planning, and strategy work, both in the public and private sector. He currently leads ACOM Philippines, computational design front, crafting next-generation design tools and methods in urban design. He's a graduate of the University of the Philippines and a registered landscape architect with over 5 years of experience in landscape and urban design. Since joining ACOM, he has been heavily involved in large-scale public sector projects that push for new sustainable communities, integrated infrastructure, and future-ready economies. He also draws upon his technical interest and expertise to drive AECOM's computational design initiatives, developing parametric urban design solutions and working to integrate these across the region. All right, so everyone, let's welcome architect Kier Pueblos. Let's give him a big round of applause. Heart reacts.
Hi, good afternoon, everyone.
Good afternoon, sir.
Let me share my screen. Okay. Good afternoon. Just before we start, a little something about me is I'm Kir Pueblos. As introduced, I'm a landscape architect and urban designer. I work with AECOM and work with a vast multitude of projects ranging from master planning, urban design, regional strategy, and aside from that, I'm also a tinkerer. Dr. Salvation a while ago noted how hobbyists are into mapping nowadays, and I would consider myself one of those. And later, I would like to show you some of the different ways I've used that to sort of encapsulate what I think urbanism is about and urban design in the 21st century. So, just a little background on mapping and urban design. So, um, let me take you back to a few maps that really um, express what I think urban design and urbanism really is about and mapping it. It's about asking questions. Um, it's about looking at urban conditions and looking at spatial environments and asking why is it this way, why is it that way. So these are maps hundreds of years ago where certain individuals looked at certain conditions such as Pianta Grande di Roma by Giambattista Nolli, where he mapped out the built and unbuilt areas of Rome. And you have John Snow's map of cholera outbreak where this was before sanitation was the norm. So he mapped out the outbreak and really looked at where is it coming from, and then he mapped out the pumping systems, the irrigation systems to look at where the outbreak was coming from. And then you have Charles Booth's maps of poverty, um, about life and labor and people in London. And so from those maps, we sort of co-opted it as landscape architects and planners. We looked at maps and said, hey, this could really help us. What if we put data and overlay it across maps, overlay it across spatial conditions, so we know what we're dealing with. And one example of this is Richard Solwerman and Joseph Fassenbaugh's Urban Atlas, where it overlaid residential land use and population density. So, and that was just the start. Of course, architects would know Ian McHarg's Design with Nature, where he really kickstarted ecological planning and looking at several layers, looking at surface drainage, looking at erosion susceptibility, to really have a more holistic environmental view of what we're planning, what we're trying to build. So with that in mind, looking at, again, going back to the concept of asking questions about urban conditions. So I think that's the main driver here for geospatial strategies for master plan development, urban design, and planning. So I'll take you through a few projects where the processes are the same, but also different ways of looking at geospatial strategies. So first is this is a coastal regional plan we did, and first things first is we wanted to look at economic potential. We wanted to look at economic development. So we went back to the drawing board and looked at economic engines. What are our population projections? What are the economic activities like fishing sites, agricultural production, tourism value, and then After that, we went to natural um, natural constraints and hazards such as slopes, earthquakes, coastal erosion, and landslide hazards, and looking at resources in marine ecology and water and irrigation as well. So from those hazard maps, from those resource maps, what we did is we made a suitability map where we sort of created a reclassified map from those elevation maps to create a suitability spectrum. And so what that means is we could then evaluate from a list of different conditions such as elevation, slope, erosion, land cover, flood and storm risk, and create a singular land suitability analysis map. And so that would then help us look at where to focus our energies to create a better master plan and the better strategy for the region. So from there, we created three different scenarios, which is the first one is nature-based scenario, looking at conservation, looking at ecotourism, and the other one is production-based, really leaning into um, industrial um, potential. And then the third one is, of course, what we pushed for is a balance between the two. So economic potential and conservation and climate sensitivity. So we mapped those out, what that looked like, and we presented the balanced focused development as the optimal solution, of course. And here's what that looks like. So looking at, we mapped out three zones where we saw great economic potential that could really catalyze development across the region. So we looked at three special economic zones, and then we also mapped out ecotourism zones through, by of course, looking back at the natural constraints. And so what did those economic zones look like? We looked at um, potential industrial growth areas. We looked at land use zones and projected those land use zones and populations towards 2030, looking at 2030. And not only did we look at these three main industrial zones, but we also looked at inclusive coastal community development, where these are pockets of little townships, small communities, whether inland or by the coast, where we saw development potential for ranging from tourism, residential, amenities, commercial, and all of that. And moving from that, also we laid out a resilience strategy where we listed water resources management, maintain freshwater, the biodiversity maintenance, protection and enhancement of ecology, and climate change mitigation. So these are several different actionable strategies, which we also mapped out with hazard resilience in mind. So we looked at the coast, we looked at mangrove areas, we looked at um, flood risk areas, we looked at potential protection zones to mitigate flooding, to mitigate storm surges. So that was one project where we looked at regional, where we looked at the region and then looked at pockets of development that could spur development and development across the region. So this one is more of looking at looking at the region, such as for this project, we looked at Luzon to Pampanga. So that's central Luzon strategy that mimics development, as you can see with our case studies from Thailand and Vietnam, where there are certain parallels with um, railways, highways, transport based development, and then seeing that as the catalyst for economic development. And then once we mapped out the different connectivity, and we also mapped out the transit networks, the freight networks. These are your industrial sites and how the freight networks interact with them. That's when we went on to develop the rest of the plan. So with this plan, actually, the tricky part about this is so I'll just skip ahead. The tricky part about this is there were already
I
several
also
master
accidentally.
there were already several master plans in place, and what we wanted to do is we wanted to have a cohesive vision. We wanted to have a singular strategy that's cohesive across different zones. And so that started also with looking at the right of way network and seeing the up top. You can see the what the current plan was for. So it's something like Commonwealth 6x6, Highway 7x7, and then we looked at capacities. We looked at um, how people would be traversing these areas. We looked at different transport networks, public transport networks, and land uses, and looked at if where these highways intersect, the land uses, and how many people would be walking. And so what we did was we optimized the right of way networks from looking at the land use plans, the development density plans. And so aside from that, we also looked at, so this is different from before where we looked at coastal resilience strategies. For this one, what we looked at was elevation as resilience strategy. So looking at um, anything below 300 meters above sea level was where the development happened. And what we did was we decided that anything above 300 was a no-go zone for development. Everything is for conservation. We wanted to maintain 60 to 70% conservation ratio. Okay, so that's what looking at bigger sites, region-wide sites and strategies. And so this one, we're looking at the site planning scale. Um, and so this is probably more familiar to as architects and landscape architects, where we look at site analysis and urban design strategies, where we mapped out what the site geometry was like, climatic conditions like your amihan, your habagat, your the inundation vulnerabilities. And then we looked at, because there was a nearby airport, small airport, but that presented us with building height restrictions. So we also looked at that and mapped it with the development zones and green networks. And along with that was urban design strategies. Again, 21st century questions, 21st century modes of thinking, where it's not about how much you build, it's about how inclusive it is, looking at green blue networks, looking at connectivity and accessibility for all, looking at development flexibility, where it's not, the term is Euclidean planning, where it's not just for residential, not just for commercial, but looking at mixed use, livable and resilient communities. And so all of those combined, we mapped out a narrative um, as looked at key moves that shape master plan. And so you can see we went from looking at the airfield as gateway for aviation and data. And then after that, we moved on to the main protection of the spine at the public shore, looking at the site geometry. And then after we looked at the coast, we wanted to orient most of the township plan towards those coasts and protect what was important. Looking at the cliffs, looking at the beach side parts of the site, and then we wanted to create a catalytic gateway here. And so this is what the resulting master plan was from that exercise. These are just images from as a result of that. And we, again, just like before, we can dissect the master plan from its layers and really look at FAR, that's floor to area ratio, and building heights. So you can map out the densities. How tall are these buildings? How many rooms can it take? How much people can it take? And looking at transport networks. Um, how are people going in? How are people walking? How do I have to drive inside? Bus networks, all of that. And then looking at your land use plan mixes, and so you know you have a healthy mix of commercial, residential mixes, while at the same time preserving your open space planning here. So from there, you can down, then get to granularity, right? The detail of this is where it gets closer to architecture and landscape, where you can design districts and what they look like, what do they feel like, um, and you looking back at the land use, of course. So commercial areas by your spine park, but in this across bisecting the site, and you have commercial areas as well, looking at the coast, looking at the protected zone. So this is what that looks like. So for this one, this is just a sample, but we went district for district, crafting an iconic character for each, whether that be from urban design or down to the architectural detail. Um, and not forgetting, of course, your resilience strategy, looking at protected areas, looking at the ecosystem that's outside the site even, and knowing what to protect, knowing what to where development should be constrained to, and then both sides, right, from protected areas where development should not happen at all, and areas where we have open space for development. So these are your different parks and different activities related to it. Okay, so that's the just went through the process of creating a master plan, creating site plans and regional strategy plans just by looking at maps, looking at the data, and then churning back out different maps to communicate that. So um, another important part of planning is stakeholders. So you can't just plan in a vacuum. You can't design in a vacuum. There are always other people involved. These are cities with thriving populations, and thriving businesses and everything. So you have to talk with the stakeholders, talk with the LGUs. And since this was just a recent project where because of the pandemic, we weren't able to go to these sites and have workshops in person. So what we did was we used digital tools, digital dashboards to converse with stakeholders, converse with LGUs using sticky notes, but using maps. And what you can learn from this is everyone can read maps. Everyone knows um, where their places are. Everyone knows if they can see a flood risk map next to their village, they know what that is. They've lived that. They know what resilience is because that's how their everyday life looks like. And so this is our interface with the LGUs and different stakeholders. And so un, not just um, oh, LGUs aren't the only ones looking at your maps. So you have to also look at how these projects develop over time and how they're presented to the constituents. So you can only plan as much, but if you can't communicate that plan, if you can't communicate those strategies, well, you've already failed. So one part of what we did was we tried to visualize um, how these projects would look like mapped out and try to make it look exciting, using graphic design and communication techniques to get stakeholders excited, to get your constituents looking at the map and seeing, yes, that would be good for us. Yes, that's a project I'm looking forward to. It's something I would support, or something that would make them participate. Even criticism is welcome, of course. So one way of inviting people in, because we all know that our profession is really skewed towards people with position, people with power and the resources. So this is a way of really inviting in people who are affected by our plans, affected by our designs. So um, here's I'll just have to breeze through this. 'Cause, I'm aware of the time. Um, Aside from looking at maps for designing cities, planning environments, and communicating designs, there's also a paradigm shift in how we use GIS. So Doc Salvation was detailed a while ago how the process usually takes. And so I'm just going to breeze through new ways of working, new ways of using maps to generate different master plans. So SSIM, or Sustainable Systems Integration Model, is system developed by ACOM back in 2014 to use maps as an options assessment and iterative process tool. So you can see how you can develop different scenarios, and it assesses it based on different KPIs. And so from those different options, you can then see how different master plan options perform. And then that way you're confident that the final master plan that the client has decided on, or that the team has crafted, hits all the right points. And so what that is it changes it from a linear um, process into a more cyclical iterative process, which we're now evolving it to call it GIS urbanism. And so what that means is using we're using GIS at both stages of recommendation and evaluation through different KPIs and design scoring. And that way you can create a master plan, and we can then see how different zones are planned and how they're suitable based on the metrics that we've assigned. Aside from that, there are different other tools like space syntax, where you can map um, the behavior, really the mobility and access behavior of pedestrians and across different scales, such as this is a citywide scale looking at Hong Kong. I'm sorry, I have to attribute this to a colleague of mine from our Hong Kong office, Sid Kakar, in partnership with HK Urban Lab of University of Hong Kong. So this is looking at space syntax applied to different scales, and then you can see pedestrian networks, shortest and most direct paths at district scale. And then you can also see it at a project scale to evaluate different plans, and then you can see pedestrian networks on both plans, and then evaluate from there. Um, moving on, this is not ACOM work anymore. This is something I've dabbled in, also looking at AI analysis for urban design, and using open data, OpenStreetMap data, um, and other data sets that Dr. Salvation also noted a while ago. So what I wanted was to look at urban density and looking at the different components of urban design to create to basically teach AI to try to craft a plan from it, looking at uh, how it can craft urban morphology and density, just given a few points and parameters. Given I gave it density maps, a height map, road network plan, um, points of interest, and it it was a respectable result. Not it's still very much a hobbyist's result, but I'm just showing how you can. There's numerous tools out there that you can just begin experimenting with, not just with GIS software like ArcGIS, QGIS, but also looking at this was done using Rhino and Grasshopper, if any of you know already use it. So these are different components that I've used to generate the urban morphology and density from these components. Okay, last bit. So looking back at the main concept that I've introduced a while ago is what does urbanism look like for 2021? Urban design is but one component of urbanism, and what it is again is asking questions. So I'm just gonna try to look at resources. I'm also looking at different institutions that are doing very exciting work, and again, asking questions about our urban condition. One of those is MIT Sensible City Lab, where they use where they mapped out taxi trails and visualizing how to optimize those taxi routes depending on um, peak hours. And then you have urban morphology, solar cities, which looks at urban morphology as it is affected by solar potential. And desirable streets, this maps out the difference between, I'm sure all of us have done the same, where we've walked a certain road, but we really prefer going a certain road rather than going to the shortest path. So this maps out what those urban conditions are, why we choose desirable streets over the shortest paths. There's also Austrian Institute of Technologies City Intelligence Lab, and they use really advanced tools to map out urban conditions and for master plan evaluation, looking at how to predict solar radiation just from feeding at different site plans, and then again feeding data to AI. There, this is a different conversation altogether, but you can get growth projections, radiation projections, and these other things. And here, I don't know if you're familiar with thinking machines, but they also do really exciting work looking at. Um, this was back in 2017. Um, they do really good visualization, data visualization of this one traffic and poverty incidents and other risks using machine learning, AI, and even just plain data visualization from ways. And, other tools like web cartography using Mapbox, CartoDB, Morphocode. Um, really, so many tools you can use to map out whatever it is that you want to map out, whether it's just for looking at different urban conditions, or whether you're using that to craft a site plan, a master plan, or a regional development strategy plan. Yeah, so that's basically my talk, and I end you with this again, this image of how mapping has been with us for so long, and how we've looked at different data points and looked at how that symbolizes urban condition, and how we've always thought, how can we do this better? How can we design better places from it? What's causing these conditions? And that's my talk. Thank you very much.
All right, thank you very much, Architect here, for that very comprehensive presentation. So for those unfamiliar with ACOM, I think they're best known for their new Senate building, di ba? So ayun, nakapunta na din ako sa office ng ACOM, very, very nice sa BGC.
Yes.
Mm-mm.
So we're working from home right now since the start of the pandemic.
I see. And the way I think of ACOM, kasi madami silang madami silang departments, is the way I see them is they're problem solvers to the problems of the built environment. Basically,
Yes.
that is. Okay, some key takeaways is it's very map heavy, right? Very map
Yes.
heavy, and we realize that it's easier to understand and evaluate information in an organized in a diagrammatic way. So those colors, even without further explanation, madali nating naiintindihan. Diba? That's an indication na maganda. We are communicating our designs well enough. Okay? At the end of the day, architecture, we need to be communicators also of our designs to the stakeholders involved. Also, creating different strategies from different scenarios. Of course, planning can go different ways depende sa sitwasyon. With all these mapping techniques, we can better devise a plan of action for different situations. All right. And lastly, the maps for stakeholders. We all know the trend now in urban design is we always involve the stakeholders in our planning. Okay, so last realization pala is we need to take advantage of technology. Kung hindi natin ginagamit to, we're missing out. And as we can see, the larger firms and the larger corporations use these tools and techniques at their disposal, and they can create intelligent and informative presentations. So again, thank you, Architect
Thank you.
here. Let's give Architect here a big round of applause. Heart reacts, everyone.
Thank you.
Okay, so moving on, let's go to our question and answer portion. We do have questions here from Architect Ian Fulgar. I think this is addressed to both of you speakers. Do we still validate the data we gather? If so, how? So let's start with Sir Salvacion.
Yes, of course, we have to still validate it, but unfortunately, there were some data set that you cannot find in the Philippines. Actually, pointing to the next, what's the problematic site? I think the site is not problematic. I think what most the problem that we most encountered is the available data sets, especially in rural areas in the countries. In Metro Manila, we could get good data sets. For example, OpenStreetMaps, the weather data sets. But if you go, for example, somewhere in Mindanao or somewhere in the Eastern Visayas, that's gonna be a different, maybe a different situation. Of course, there are even published the literature, there are published research uh, uh, on validating these data sets. We're trying to validate additional data sets, but again, that's what the problem in our country. Because sometimes when you go to LGU, when you talk to them, you have this data, and they can say, we thought it was not needed anymore. It's already 5 years old, so we just throw the data set away or put it in somewhere so we cannot find it anymore. So it's really that's really the problem when you're dealing with planning or data planning in the Philippines.
Yeah, especially we go open source, yun talaga yung problema, yung inaccuracies, mga false data. So, as you have mentioned, may may moderating body dito sa mga GIS softwares natin. Architect here, your thoughts, please.
Yeah, about that as well. We absolutely have to validate data, but of course, with the pandemic, it's very hard to um, do anything else aside from looking at the data set that we have. And as architects and planners, also our huge limitation is if the client holds the data, meaning the resulting plan that comes from it is of course based on the data they have. And I know there are certain initiatives like counter mapping where, for example, you have minorities and marginalized communities. They're not part of the map. So if a client has a big map and they say, oh, these are where the population resides. So you would plan based on that, not knowing that there are communities in there. So again, it's hard and it's trickier now with the pandemic. Um, but absolutely, it's necessary also to look at other resources, and if there are other institutions out there that could give us a second opinion.
I see. So do your own research pa rin sa approach nito. All right, so that's a very good question from Ian Fulgar. Now we have a question from Sir Aaron Desciones, faculty ng UP. This is addressed to Dr. Salvacion, Dr. Arnold. Can the flood risk assessment approach for Marinduque province be used to do the same assessment in a smaller scale, urban design scale, say a central business district or a specific neighborhood?
You can, but I think for small scale, those small scale assessment, you might use a different model so that you generate a more site-specific or a more granular results compared to what we did in Marinduque. Because this one, the one we did in Marinduque, this is just based on logic or expert opinion, but there are different other models that you could use, especially if you have a more granular data set.
I see. So again, it can be scaled, diba? Yung GIS, pwede siyang neighborhood scale, town scale, city scale, national scale, global scale, international scale. So many applications, as Dr. Salvacion has mentioned. Question from Ma'am Shell Maria. So addressed to both of you. Among the projects you have worked on, which site was the most problematic, highest climate change risks, and what strategies did you use for the master planning? Has your institution, company, been able to propose new theories and concepts for climate resilient communities with the projects you have worked on? To get from architect here, please. Good, sir.
Yes. One. I wouldn't. I don't know if it's the most problematic, but a thing that we always grapple with is when we work with developers, they have targets, they have metrics that they want, revenue targets, and most of the time they want their bottom line like checked, and so sometimes the terrain, the topography doesn't agree, and we can say that, oh, we can only look at the suitable development area at this much. And so it's something that we have to fight for also. And we have to we have to be frank with the developer and say, this is what we can do and at the same time have those principles in mind, where we have to say, this is the resilience strategy you have to employ. This area is a no-go zone. If you do this, you're going against your 100-year flood zones, 50-year flood zones, and all of that. So that's the main um, conflict always with developers who have their revenue targets, which aren't aligned with topography. That's one.
Sir
Looking at,
Salvacion,
sorry,
I'm
go ahead.
sorry, please continue. Go on.
I was just looking at going for the second question, which looks at new theories and concepts. I wouldn't call it new theories and concepts, but um, again, we really look at climate resilience strategies and how to stay true to that, and make sure that we don't design another Metro Manila. We don't design um, another space where it's all for um, development is only for not inclusive, so to speak. Um, so yeah, it's less about proposing new theories and concepts. It's more of pushing for those already tried and true concepts, which again, developers will also try to push back on. So there.
Dr. Salvacion, your 2 cents.
Okay, on master planning, I had not done master planning yet, but as I mentioned earlier, with my research projects or land use planning projects, um, one of the problematic is, of course, is the data. Then if there's are some politicians who have want to, for example, they even though this, as mentioned the architect earlier, even though this area is a no-build zone or cannot be for development zone, they will push for it. So that's really, hard to how to deal how to deal with it. Um, for those cases, mahirap talaga kasi sila yung kliyente mo and then they will, they will impose themselves on you So, pag ganon, parang tumatahimik na lang ako kasi mahirap din talaga makipag-diskusyon. Kasi they would say, hindi kasi sabi ni ganito, sabi ng ganyan ko, ganito yan. Hindi ito yung data This is what data is saying So, sinong papaniwalaan ko? Sinong susundin ko sa inyo? So, but I think sometimes you have to be firm on your stance. Kasi, or else, if you allow it, siyempre, baha na naman or any disaster could happen in any zone So, we're just waiting with the climate change. So, ayaw mo namang, alam mo yun, the back of your mind, you already warned them before. And yet it happened. So, it's really hard. Mga depende yan sa LGU. Ayaw kong sabi ng LGU, pero yun yung dyan. LGU, yung mga politiko na nakikialam sa
Tama, sir. Tama pa. All right. So moving on, what about our students here? We do encourage na yung question from our students. Pwede kayo mag-unmute or you may type it in our chat box and we'll entertain your questions. Especially from the class representatives or batch representatives. Pwede kayo magtanong about your plates, about your projects, especially with regards to this topic, GIS. Anyone from the class? Anyone from the UP class? All right, sige, ipopost nyo na lang dyan. Then, from Lian Ong. May I ask if you could recommend any open source GIS software open to us students for site analysis and other architectural data gathering? Very good question. Sir Kier, what do you recommend accessible for us students? Something na hindi ka na kami magsusubscribe ng thousands of dollars.
Oh, QGIS. It's free. Any free software is good in that whether it's 3D modeling or mapping like GIS or Blender. Because it's free, it's open source,
Mhm.
and it means it's not pros and cons really. So sometimes the cons would be it's not what people would call industry standard. People will always look at ArcGIS for everything, but especially on our end, our GIS team will always use ArcGIS. But um, once you get the concepts down of mapping and just turning on and off the layers, putting in the shape files, and then looking at your site and then seeing go inside yung site ko with yung um, storm surge na layer from the shapefile. Just that practice of putting in data and basic mapping is already enough to get started as a student.
Sorry, what's the software again?
QGIS.
QGIS.
Yes.
Okay. Sir Salvacion, what's your recommendation?
Syempre ako I'm a proponent of open computing. So I propose QGIS. Additionally, it is a cross-platform. So you could use it in Mac, you could use it in Linux, you could use it in Windows. The problem with the ArcGIS is you could only use it in Windows. And of course, the cost of it. That's actually my persuading statement to my students. If you're given a 1 million budget project and you'll do some GIS on it, what you're gonna use? If you use ArcGIS, you cut half of your fund just to buy software, and then you use the other $500,000 for the MOE or the very expensive. But if you use open source software like QGIS, you could get the 1 million profit easily. And the other thing, if you could study more, I suggest you also study Python or R software, because this could help you with those repetitive tasks. You could just automate it. Could easily do some, especially if you're dealing with multiple data sets. Because if you do it, for example, what I did in mapping the drought hazards in the Philippines, so from 1958, so it's more than thousands of layers of GIS that process. So if I do it in QGIS one by one, it would take me maybe a year or so just to finish the processing. But Python, I think Python is already incorporated with QGIS. You could use Python. But generally, I go for QGIS. If you're want more advanced, you could go for GIS, but I think the principles are the same.
But it's very doable without Python kasi mahirap din yung Python matutunan. Codes
Yeah, I
siya,
think
di
it's
ba?
doable.
Yeah.
Yeah, QGIS is similar. Actually, there I think 2004, 2007, there were issue with with ArcGIS and QGIS. They were saying that ArcGIS copied the interface of QGIS during that time, something like that. So they're similar.
Just a little follow-up regarding the question about the barrier of entry. I'm speaking specifically with the learning curve. Accessible kaya siya? Ilang araw ba siya bago matutunan? Or I'm asking about the difficulty of the software to learn. So mga gaano po kaya siya kahirap?
Yeah. Parang AutoCAD lang din siya.
I see.
Yung difficulty niya, it's only intimidating if you're looking at it from the outside. Of
Mm.
course, it gets more intimidating the more you know that you don't know that there's many other methodologies. I'm looking at Doc Salvation's work a while ago, and it gets the curve gets way up, of course, but the barrier for entry it's the same as SketchUp or AutoCAD.
I see. All right, so medyo naubusan na tayong oras. We have last question from Beulah. Question from Beulah Perez. For both speakers, may I know if you're using statistical algorithms other than visual analytics in studying your data sets? If so, what types of special algorithms are being used, i.e. regression analysis, etc., and the like? So, Sir Salvacion, please answer.
So on my work, I use a lot of different statistical techniques and machine learning techniques with my data sets, because sometimes GIS, especially in the field of science, presenting data in GIS will not get published. So you have to incorporate more statistical analysis or machine learning techniques. So some of them are support vector machine, random forest, maximum entropy, and the similar statistical tests that we could use.
I see. So last question from Pars Eleanor Kinay. Who professionally signs on the approved urban design plans from your company, Sir Kier? Can you please answer this?
So for especially for the projects that I showed, before going into project with the government, obviously you have to bid, and so with bidding requirements, you have required professionals for any project, and that's we have a wealth of experts and local consultants as well to help us with that.
All right. Thank you for the answers, Sir Akir. Okay. So I think meron pa naman tayong 5 minutes, so might as well. Are the maps and other results easily transferable to other Archi programs like Rhino, CAD, SketchUp, and Illustrator, so we can also make our maps look nicer? Sir Salvacion, please.
I think you could transfer it. I think on QGIS there's a I think a function you could
Export.
convert shapefile to export shapefile to AutoCAD. Wala pa masyadong experience dito, but I think architect here.
Yeah, I believe tama. May na-experience din ako na press the button and may export siya, especially to CAD kasi well integrated talaga yung AutoCAD sa iba-ibang third-party soft programs. So from Ulysses Paredes, do you think that a research based on tongue twister spatial-temporal analysis of land, urban green spaces, for example, can be a basis of future developmental controls such as those found in PD 1096 or the National Building Code of the Philippines? Sir Kier?
Definitely. I mean, not just urban green spaces, of course, but we always look at the building code and then put it up against what we want to accomplish. And actually, to be frank, it's quite outdated with more contemporary standards of development, such as using mixed uses, non-Euclidean planning, where popularized by American cities, where this site is just for for residential, this is just for commercial. So you get less granularity from that. And so looking at the building code and looking at its different statutes, it gets difficult trying to insert new, more inclusive ways of designing cities. So definitely, in terms of the institutional feasibility of getting that done, I'm not an expert of looking at changing PD 1096 based on more contemporary land use analysis. So, but from my experience, we would definitely prefer to evolve it to more modern standards.
Architect here, any particular design or planning interventions that you employ in your projects to make cities more adaptive to climate change?
It's I in terms of planning interventions, it's really there's a standard palette, I would say, of what you can offer as a as to say it's adaptive to climate change, but it really varies project to project, and looking at the context and saying, oh, this is a coastal project, oh, this one's more inland, this one's highland, and mapping that with not just the natural constraints, but also looking at the goals of the developer, the goals of the planner as well. So how it's really different from project to project, but um, it's all about priorities and having a set standard for that palette, for that climate adaptive strategy palette. But yes, um, yeah, I think I answered the question.
Okay, so yung question ni Sir Chester, we can follow up na lang, baka okay lang ba na i-email na lang natin yung questions, then i-answer na lang natin through that kasi medyo gahol na tayo sa oras. So okay, before we go to the ending remarks, let's all thank our speakers, Dr. Arnold and Architect here, for their very informative presentations. Also acknowledging the organizers of this event,
Thank
the
you.
Architectural Communication Studio and the Urban Design Studio Laboratory. Acknowledging also the members, Sir Frederick, si Sir Aaron, Ma'am Karen, and Ma'am Anna, of course, Ma'am Shell, and since medyo populated yung list ko, to all of us and me, the speaker. Now let's proceed to the awarding of certificates. Please, Ma'am Anna, flash the screen of certificates. All right, we're having some technical difficulties, but we're presenting this certificate to Sir Arnold Salvation. Thank you very much. We'll just follow up regarding this. And to Architect Kier Pueblos, presenting this certificate of appreciation for your contribution to this to the students, to our audience. All right, so let's go to the closing remarks by Sir Frederick Santos, the head of Architectural Communication Studio Laboratory of the College of Architecture of UP Diliman. Thank you.
Yes, thank you. So as was just clearly shown to us, there are two speakers. GIS as a tool opens up a whole range of information that we just wouldn't be able to see through our own observations and experiences. It can make it possible to see both direct and indirect causal relationships, and even show how something that happened a long time ago could affect our designs and plans today and into the future. Especially useful in the realm of climate change, which is an immediate issue for us today. For us in the architecture, LA, and planning world, this gives us the opportunity to be more proactive with our designs, making them just a bit better at answering the many challenges thrown at them and us. For the professionals, you've seen how GIS can be useful for a more robust output. And for the students, we hope that what you've seen has given you a renewed confidence that even now that we're stuck at home, the data is out there. And the only issue now is how to find it and dig through it and use that information to be applied to your projects, especially to those fifth years who are now combing through a ton of data that they can apply to their final CDBs. We from the UP College of Architecture hope that you've learned something that can be immediately applied to your concerns. And just to let you know, the college is now working on ways to include GIS formally in our coursework. To our speakers, thank you for sharing your knowledge. And to the audience, thank you for attending and listening to our speakers.
All right, thank you, Sir Edric. Again, coming from Sir Edric, take advantage of the available tools. Technology is the future. We need to make use of it. All right, so I'll just we can flash na pala the certificates. So once again, the certificate of appreciation for Dr. Arnold Salvation for his valuable contribution as resource speaker, presenter, at Geospatial-Based Analysis and Visualization Approaches in Urban Design for Climate Action, held last October 11, 2021, 3 to 4:35 p.m., organized by the University of the Philippines College of Architecture. A big round of applause, everyone. Now, presenting the second certificate to architect Kier Pueblos, again for his valuable contribution as a resource speaker or presenter at Geospatial-Based Analysis and Visualization Approaches in Urban Design for Climate Action, held today, 3 to 4:35 p.m., organized by the UP College of Architecture.
Thank you.
Now let's wrap up this webinar. I hope everybody learned from our two masters, two presenters, and me as well. I get excited because I'm already looking into this the past few months, especially for my past project with the firm I was with, GIS, Geographic Information System. Let's all take this into account. This is more of a discipline, not more of a tool. Kasi para siyang building information modeling if you're familiar with BIM, parang ganun. All right, so from Ma'am Ana, we request everyone to answer na lang the feedback form. We'll email a certificate of attendance once you have completed the form. All right, so thank you everyone. Have a great week ahead. We may now leave this webinar. Thank you very much.
Thank you. Ingat kayo lahat.
Thank you, everyone.
Picture pala. Sorry. Okay lang ba?
Oh, yeah,
Picture.
picture.
Gosh, nakalimutan ko. May nag-exit na tuloy. Sorry. Okay, sige. May we turn on our cameras muna? Ma'am Ana, please do the honors of taking pictures. So screen 1, smile. Screen 2. Then screen 3. Thank you, everyone. Have a great week ahead.
Thank you. May we request the speakers to stay also and the organizing committee so we can have our photo shoot.
Anna, should I just remove the rest? Oh, there.